Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about the power rule of finding a derivative. In the last video, I introduced the chain rule, and we're going to be using the chain rule to develop the power rule. We actually were finding derivatives of power functions in the last video. So if you haven't seen that video yet, I recommend it because I think that this video will make more sense. We talked about the chain rule, which is a rule that you use if you have a composite function. So that means if you have a function within a function. So we were looking at polynomial functions within power functions. And the chain rule says that dy dx would equal dy du, where u is kind of the outside function, so the power function, times du dx, that's the derivative of the inside function. So this is the derivative of the outside function, this is the derivative of the inside function. So this would be the derivative of the power function, this would be the derivative of the polynomial function inside. So instead of referring to the chain rule, we're going to make an actual rule for a function like u to the n. So if you have some function of x that we'll call u, raised to the power of n. Right now, the only kinds of functions of x that we've been looking at have been polynomial functions, but this is going to extend to other functions later on. So the chain rule allows us to develop the formula for finding the derivative of a power. And that rule will be dy dx will equal the derivative of y with respect to u, so that will be n times u to the n minus 1. The important part that we can't forget is the du dx. So I'm just going to make a note, do not forget. I see students forgetting that all the time. So let's take a look at some examples and just practice using this rule. So our first example, y equals this function to the power of 6. Here's our rule. So the derivative of y with respect to x, dy dx, will be equal to n, which is 6, times u, which is this whole function, 4x squared plus 5x minus 1 to the power of n minus 1, so to the power of 5. And then we have to multiply by the derivative of what's inside. So the derivative is 8x plus the derivative of 5x is 5. Derivative of negative 1 is 0. That's it. Let's try another one. All right, our next example, we have a constant times a function, and that function is a power function. We do not need to use the product rule because it's not a product of two functions, it's just a constant times a function. And one of our earlier rules said that when we have a constant times a function, we just leave the constant there and multiply by the derivative of the function. So when we're finding this derivative, it's going to be 5 times whatever the derivative of this is. To find this derivative, I can use my power rule. So it will be 4, which is my n, times u to the n minus 1, so 4 minus 1 is 3. Don't stop there. Don't forget to multiply by the derivative of what's inside the brackets. So we need to multiply by the derivative of 10x squared is 20x, minus the derivative of 3x is 3. That's the derivative, and you probably would clean it up a little bit. So we could have 20, and you could multiply through 20 to 20x minus 3 if you want. You cannot multiply it through to this because we have a power other than 1. I'm just going to leave it like that, and we're done. Let's try some more. In this example, we have y equals 5 over square root of x to the 4th minus 3x squared. It is a quotient. However, our numerator is constant. So you could use the quotient rule to differentiate this, but you will end up doing a little bit more work than what I'm going to show. So it's possible, but I'm always trying to think, what's the easiest way to do this? And because it's constant, I can rethink this or rewrite it as 5 times x to the 4th minus 3x squared to the power of negative 1/2. Because this square root means it's to the power of 1/2, and when I bring it out of the denominator, it becomes a negative exponent. Now I just have a constant times a power, so my derivative will just be that constant times the derivative of this power, where I use this rule, where n is negative 1/2 times u to the n minus 1, so x to the 4th minus 3x squared to the power of negative 1/2 minus 1 is negative 3/2. Then I need to multiply by the derivative of x to the 4th minus 3x squared, which will be 4x cubed minus 6x. And then I would clean this up. I'm going to multiply negative 1/2 times 4x cubed minus 6x. I'm going to put this value in the denominator so it becomes a positive exponent of 3/2. And if I distribute the negative 1/2 here, I'm going to get negative 2x cubed. When I multiply negative 1/2 times negative 6x, I get plus 3x. And then I could write that, I could either just change the order here, or I could multiply 5 through my numerator. So I'll get 15x minus 10x cubed over x to the 4th minus 3x squared to the power of 3/2. We could have left the 5 factored out. I like to change the order of the terms when you have that situation, because if you have negative a plus b, that looks a little more cumbersome than b minus a. I prefer that. So this would be correct. This would be, in my mind, a little bit simpler. Let's try a couple more. I wanted to do an example where we were working with s in terms of t, which is what you will encounter if you're working with displacement in terms of time. Same rule. I'm finding ds dt. It's a power, so I use my rule, 3 times my u, which is 3t squared minus 4, to the power of n minus 1, which would be to the power of 2. And then don't forget about multiplying by the derivative of what's inside. It's this time, though, it'll be with respect to t. So the derivative of this will be 6t. And you might want to combine your factors. 3 times 6t, which would be 18t, times this power, and we're done. Let's take a look at one last example. In this example, we have w is equal to the square root of 2rh minus h squared. So we actually have 2 independent variables. So you'll have to be told which variable you want to differentiate with respect to. So they're saying find dw dr. So in order to do that, let's write this as a power first of all. So it's the power of 1/2. So now when I find dw dr, I do this first part the way I always do. I take n, which is 1/2, times 2rh minus h squared to the power of 1/2 minus 1, so the power of negative 1/2. Now I multiply by the derivative of what's inside. Keeping in mind that r is our variable, which means h is a constant, we just don't happen to know its value. So the derivative of this term is like 2h times r, so a constant times r, and the derivative of that is just 2h. Minus the derivative of h squared. H is a constant, so h squared is a constant, so the derivative of that is 0. So that would be the derivative of inside with respect to r, treating h as a constant. I would clean this up. 1/2 times 2 is 1 times h. And then I would put this power in the denominator so that I could have positive exponents. That would be the derivative with respect to r. If we were asked to find dw dh with this function, we would start off exactly the same. It's going to be n, which is 1/2, times u to the n minus 1, so 1/2 minus 1 is negative 1/2. And now when I go inside to find the derivative of this, I'm finding the derivative with respect to h, so that means we treat r as a constant. So the derivative of our first term will be 2r times the derivative of h, which is just a 1, so it would be 2r, minus the derivative of h squared with respect to h will be 2h. Now I'll just simplify this. I will combine the 1/2 with this factor, which gives me r minus h, and then I'll move this factor to the denominator so that I have a positive exponent. So the derivative changes depending on what you're differentiating with respect to. The first part is the same, but it's the second part when you actually get in and differentiate the function inside that you have to be paying attention to what's constant and what's a variable. So my recommendation is to practice just working with the power rule on its own, just functions that have the power rule. Because in the next video, what I want to do is combine power rule, quotient rule, and product rule, because you're going to get functions that have all of that going on. So make sure you're comfortable with power rule as well as product rule and quotient rule, and then we'll throw them all together in the next video. All right, take care, and we'll see you then.